Section 4.5, we're talking about the fundamental theorem of algebra. And the big conclusion that is derived from that theorem is that if we count each multiplicity and all complex roots, then the number of roots is exactly equal to the degree of a polynomial. So complex roots. So far we've talked about real roots, positive and negative real roots. So that's a set of numbers, the real numbers. And then that is actually a subset of the complex field. In the complex numbers, we also have everything with an I. So we learned about complex roots a little bit. We touched on it a little bit in Unit 1. So we saw things like 7i and 3 plus 2i and things like that. So those were not real numbers, but they are part of the complex plane. Complex. So the complex set of numbers is the larger set. It has real parts. So we talked a little bit about this kind of thing. It's got an imaginary part and a real part. So the real numbers are part of that because the number in front of the I can be a 0. And the pure imaginary numbers are also part of that because the real part could be 0. So the complex numbers includes the real. So when I say it had a 5th degree polynomial has 5 complex roots, some of those may be real, but no more than 5 roots. No more than 5 roots can be real because there's no more than 5 roots. There's exactly 5 roots in a 5th degree polynomial. All right. The other thing is that when I do have a complex root, I mean a root with an imaginary part. So for example, if 7 plus 2i is a root of a polynomial, then its conjugate, which is 7 minus 2i, is also a root. So the fun thing about complex roots is that one's a freebie. So as soon as you find one, the other one's a freebie, and you found 2. Now, one thing that's special with the complex roots is that, or I guess not special, is that they're not the y-intercept. So when I find my polynomial like this, this right here, these are real roots. Real roots are the ones that correspond to an x-intercept. Whereas over here, I see there's going to be another root, but it's not visible on my xy graph because it's imaginary. So there's got to be an imaginary part to that root. It's not going to correspond to the x-intercept. So even though I have a 5th degree polynomial has 5 complex roots, I only get an x-intercept. Only the real roots correspond to an x-intercept. So the complex roots aren't going to help us with graphing. Okay, so for section 4.5, you have the Math is Fun assignment, and you have the pre-lesson. Those are both in Math 093. And then for 103, you'll have a short classwork quiz, and that's it. So no homework for section 1.5. I mean 4.5, sorry.